All right, so we've analyzed the numeric to numeric relationships. Now it's time to turn our attention here to the categorical variables. We need to understand how sex, smoker, and region impact or explain their insurance charges. Now, factors like sex and smoker that have only two groups, these are fairly easy. We're going to start by simply creating a bar chart. So click on column A, and then hold down Control, click on column G so that you have both of those selected. With those selected, go to Insert, click right here on the bar chart, grab this very first one. Oops, that's not the way I meant to do that. Instead, go to Insert, Recommended Charts, and then they call it a clustered column chart. Tableau handles this a little bit smoother, but at least Excel makes this possible. Back in the day, it was a lot more painful, but this is basically what we want right here. So click OK. And I'm going to, we can leave it over here. This is fine. So it created basically a pivot table where it divided female and male into, they've got the sum of charges here. This is close, but not exactly what we want. So we've got these two bars, but the reason why sum of charges won't work for us is because, well, what if we have more males in our sample than females? If we do, then it makes it look like men cost more than women, and they may not. So what we need to do is come over here and change sum of charges. Go to value. Sorry, you probably can't see this. Let me try. I have to move this up for you here. There we go. Go down to value field settings. Move. Oh, it won't let me yet. That's fine. And change this sum down here to average. Double click or single click and OK. And bring this down here again. All right, there we go. So it says sum, but it is not sum. Can I change that? Oh, I guess I can just type it in right here. I would call this just simply charges by gender. And all it's doing is it's giving us the mean right here for female and male. And male looks like it costs twice as much, but it doesn't. Why? Well, take a look at the scale over here. This is fine. You can do this, change the scale. The advantage of this is it highlights the difference between them. But for doing data exploration, I actually don't like that. So I want to come here and format access and tell it, let's make the minimum 0. And there we go. Enter. There we go. So now we can see that yes, men do cost more, but it's only by a little bit right there. But is that enough to say that gender is a good predictor of insurance charges? So that's a different question. We start by visualizing with a bar chart, but to understand if gender really explains insurance charges, we need to calculate a couple of statistics, a t-test and a p-value. So a t-test in Excel is actually really simple to do. However, you have to have the data in the right format, and that part's kind of a pain. So here's what we're going to need to do. I'm going to move this over here and actually call this one sex so that I have a different sheet for each categorical variable. I'm going to come back to insurance, and I need to get all of the charges for men and all the charges for women. So to make that process easy, I'm going to insert a table over my data first. Yep, that's what I want. Now I'm going to sort A to Z, and I'm going to get the charges, not the word female, the charges for all females. So I'm going to hold down Shift, page down until I get through to the males. Let's see here, still going, no, there it was, back up, page up, down, right there. There's all my charges for females. I'm going to copy. Paste, and I'll put here female, male. I want to go back and get all the charges for men right here, and since I've already found where it changes, I can just hold down Control Shift down arrow, Control C to copy, Control V to paste. Okay, now the t-test is going to be a bit easier. We could have done it over on that other page, but you'll see why I did this. I'm just going to go to equals t.test right there. And look what it's going to return. It's going to return the probability associated with what we call students' t-test. The probability is actually the p-value. So a t-test value, a t-value, and a p-value are actually two separate things, but they're perfectly correlated with each other, meaning a t-value gives you an exact p-value. And so what we're really interested in here is the p-value, and so we can kind of skip getting the t-value, and Excel will automatically go straight to the p-value for us. Here's what I mean. So it says it wants two arrays. Here's my first one. So unlike that correlation matrix in the prior video, we don't want the labels, just the values. Control Shift down, comma, Control up right here, Control Shift down, comma again. All right, so we've got the two arrays. Let me scroll up so you can see where we're at. Now it says it wants this thing called tails and then type. So tails is something that refers to whether or not we know or have a theory that says we believe men should cost more than women or that women should cost more than men. Well, what's our theory? It's our explanation for why we think what our hypothesis will be what it is. In this case, you could argue, well, women cost more because of childbearing. They're more likely to suffer physical harm from that. Or you could argue, well, men cost more because men are known to have poorer eating habits, more heart problems. These are facts and statistics. I'm not giving a personal bias here. And so we don't really have a solid theory whether one will be higher than the other. In that case, we want two tails. Now, if we did have a theory that could logically explain why we think one would be higher than the other, I would make it a one tail. And it doesn't matter which one's higher, just that we have a high expectation that one will be higher than the other. And all that does is it's going to make it twice as easy to get a significant p-value. Anyway, I'm going to go with 2 since I don't have a good theory. Lastly, it says type. All right, now let me open up the f of x here so you can see what type is. So if I click on this, it gives us 3 kinds. Paired equals 1, 2 sample equal variance equals 2, 2 sample unequal variance equals 3. So paired is not what we're dealing with. That would be when you take the same person and maybe measure their weight or charges at 2 different times to see if they're different. These aren't the same people. Men and women are independent. These aren't the same participants, so it's not going to be number 1. Next question, is it number 2 or number 3? What is variance? Well, it's a function of the standard deviation, which you may remember what that is. So if the standard deviation for men's and women's charges are the same, then we would use number 2. It doesn't have to be exactly the same, just close to. If they're not, then we'll use number 3. I'm going to start by assuming they are the same, so I'm going to put in number 2, and then we'll check it. So, okay. This is our, again, not our t value, but our p value. So as a reminder, I know some of you get p values and some of you don't. It's kind of a hard concept to understand at first. But this is the probability. Now, probability varies between 0 and 1, right? So think of it as a % likelihood. And in this case, it's actually the % not likelihood. It's the likelihood that if we were to collect another 1338 samples, that these 2 bars would look different than they do right here, that we get some different result than what we're seeing in front of us. So this says there's only a 3.6% chance that next time we collect data, these bars might be reversed, where women are higher. That seems very unlikely, right? It tells me that there's a 96.4% chance that the next time I collect data, men will be higher once again. So in that case, I'm going to reject the null hypothesis and say that men and women are different, and in particular, men cost more than women. So this is the p-value, and I get it from running a t-test. We use this whenever there are only 2 bars or 2 groups that we're comparing. Now I told you before that I need to check our variations. So there is a formula for variation, and standard deviation is just the square. So I'm just going to go ahead and do the standard deviation since most of you are familiar with that. I'll put them right here. This equals whoops, st, here we go, standard div. If it's .p is if you know that you have data for every possible person in the population, which is almost never true. Standard dev.s means that we just have a sample, which is almost always what we do have. So I'm just going to come down here and grab Control Shift down, everything in that list. Same thing over here, equals st dev sample, everything in that list. And say, relatively speaking, are these standard deviations pretty close? Well, how close is pretty close? Let's just see how much % different they are. So I'm going to take men, and actually what I need to do is say, put a parenthesis first, then say men minus women divided by men. So how much different are women than men? 14% different. I'd say that's close enough that you could assume that this is equal variance and stick with a 2. If you're curious what would happen if we did make it a 3, let's just find out. Let's change this to a 3. And our p-value is just slightly smaller. Not a big deal. So for the test in this class, we're not going to make you go through and do standard deviations. I don't know, your individual instructors may vary, but this is just sort of so you could understand this t-test formula. Okay, so that's when we have 2 groups. Let's do one more example. Let's go to region where we have 4 groups. This one's just slightly more complicated. So what I'm going to do here is once again sort by region. Well, actually no, first I'm going to make my bar chart. That'll be simpler. So let's go up here, select all of C, all of G, insert. So the recommended chart gives us a cluster chart. We can find cluster chart, not under bar chart. Not under there. Oh, no, I can't even remember where it is. But that's fine. Oh, is that it? Clustered column with a line. That's kind of cool. Let's do that one. Oh, I do have 2 series of data. All right, you know what? Chill. We'll just go on back to our recommended chart once again. Select this clustered column. Okay. All right. So here's our sum of charges by region. Don't forget, once again, we don't want sum. Come over here and change it. I know it's off the screen here, but remember on the last one, I just scroll down until I find value field settings. Select it, change it to average. Okay, that's a bit better. So southeast costs the most, followed by northeast, northwest, southwest. Now, the only difference between what we're doing here and what we did before is we're not just comparing 2 bars, but we're comparing all 4 bars. We want to know, in general, is there an overall effect of region that explains charges? So we want a visual. We've got the visualization that shows us all 4 bars at once. That's easy. But now we need a statistic that will look not just at a pair of bars, but at one how many pairs total? This one to that one, this one to that one, this one to that one, that's 3. And then this one to here, this one to there, that's 5. And then this one to there, that's 6. So we need a formula that will do all 6 pairwise comparisons and sort of average them together and tell us, is there a statistically significant difference when I look at all 4 at once? Well, there's a perfect test for that. It's called ANOVA. In order to run it, we're going to have to get the data like we did last time and put it into columns. So let's call this region. I'm going to move region out here. By the way, when I do consulting, usually what I'll do is I'll break out this analysis on a different tab for each variable. So I'd put this BMI when we did previously, the scatter plot, all on its own tab too, but I'm going to keep things brief and not worry about that. Instead, I forgot, I need to come here, I need to sort by region first. And let's start by grabbing all the charges for Northeast. Whoops, that is not what I meant to do. You do just shift page down. Shift page down until I get through all the Northeast charges. Now remember, I'm copying the charges column, not the region column. Oh, there's Northwest. And go back right here, down to there. Control C to copy. Control V to paste. didn't like something I'm doing here. Let me grab this and go back up. Copy one more time. Shouldn't have a problem with this. Oh, there we go. Who knows what it was doing. All right, let's call this one northeast, the next one northwest, southeast, southwest. Okay, perfect. Back here, let's go down. Oh, I'll just scroll to right here. Shift page down until we get to southeast. There it is. Okay, there's northwest. Look on the first charges for southeast. Shift page down until we get to southwest. Control C to copy. Control V to paste. Last one. Start on the first one of southwest. Control Shift down. Control C to copy. Control V to paste. Okay. There's all of our data. On ANOVA, we're going to calculate that by going to that data analysis tool pack again that we use for the correlation matrix. So go to data, over here on data analysis. And again, if you missed the first video, if you don't have data analysis, you need to go to File, Options, Add-ins, Excel Add-ins, Go. Click right here, check the box on Analysis Tool Pack, hit OK. All right. Once you do that, you can go to Data, and you'll see this data analysis right here. Go to ANOVA Single Factor, Input Range, select all of this data, including labels. And you do need to Control Shift down until you get through all of them. So notice that southeast is more of those. Make sure you go all the way to the bottom, and it's not a problem that there's a bunch of empties in the others. Check labels in the first row, click Output Range, then click over here into this box. Control up until I find a good place to put this. Let's do, I'll put it all, what is that? Right there, beautiful. Okay. All right, so here's what we've got. The ANOVA starts by going through each of our groups, gives us a count of the number of samples we have, sum, average, and variance. So again, variance is just the same as standard deviation squared. Can I extend that out? There we go. So I would take the square root of this to get down to the standard deviation. I may have said the opposite before. Anyway, just so you can see the relationship there. Equals that raised to the 1 divided by 2. That's our standard deviation for each of these groups. To me, those standard deviations look pretty close. I can also see it from the variance. They're close enough that I would say I'm going to assume equal variances for all of these. All right, down here we get this interesting table. And I'll explain what's going on in this. It takes several calculations to get to the point to where it can come up with what's called an F critical value or an F value. And it gives us a p-value along with it. So the sum of squareds is basically telling us the between groups is telling us how much variance is explained by different group values. So by this being northeast, how much variation from here to here is being explained knowing the difference between northeast and northwest. So the sum of squared residuals within groups, sum of squares within groups tells us how much error or noise there is within each group. So it's taking these variances, well, not really the variance, but basically saying, all right, how much does the charges for northeast vary within itself? How much does northwest vary within itself? And it gives us another number. And so then we use these numbers to calculate what's called mean squares. And degrees of freedom, this tells us how many different groups there are minus 1. This is number of groups 4 minus 1. Within groups is the number of rows minus the between groups minus 1. So that's our 1338 minus 3 minus 1, and then total is just the sum of these together. Mean squares are then used. We simply take between groups divided by within groups, and I can show you here this equals that divided by that, and that gives us the F critical value of 2.96. So before, remember when we did the t-test, there was a t-value that it never really showed us because it went straight to the p-value. Here it's actually giving us the F value. And the only difference is that we use an F when there's more than 2 groups, and it'll be a t-test when there's only 2 groups. Here's our p-value based on that F. So this p-value is once again below the cutoff of 0.05, and we'd conclude then that there is a relationship between region and charges. Something about region is reliable and predictive. We can count on the southeast costing more, and the southwest costing the least, and the northeast and northwest being here. If we were to collect more data, we'd expect to see that again. That's what this p-value tells us. Now we can go through and compare individual values. We could do a t-test between northeast and northwest. If I combine those, home, merge, I could simply say equals t-test, and I'd come down here, grab that one, comma, come down here, grab that one, comma, and just say 2 tails, type 2, enter, and it gives me a p-value. This is the p-value of a t-test comparing northeast to northwest, which says those two are not different. All right, let's do, and that we can kind of predict, right? Northeast and northwest, there's not a huge difference between those. If those aren't different, I bet we can count on northwest and southwest also not being different. But southeast, all right, let's do southeast to northeast. Well, let's just go for the big one. Southeast to southwest right there. Merge those. Equals t.test array 1, comma, array 2, 2, 2, enter. All right, in this case, that is a much bigger difference, and so the p-value is much lower, 0.01. Notice how the p-value for all of them together is kind of in between the most extreme and one of the lesser extreme paired differences. That's usually going to be the case. However, just so you know, it is possible that all of the pairwise p-values could be non-significant, but yet the overall p-value of the F-test is still significant. And if that happens, that's okay. We can then conclude that there's an effective region on insurance charges, or something about region that can predict insurance charges. All right, I think that's enough for this video. That's how we handle categorical to numeric relationships when we're exploring data.